Hello everyone, and welcome back to another lesson in learning the basics of Java programming. So far you guys have learned about the IPO model, where the I stands for input, the P stands for processing, and the O stands for output. And with regards to output, you've learned about the print commands. And these are associated with the console, and there's print, which will print and leave the cursor on the same line. And then there's also the command print with an ln at the end, and that will put an enter at the end of what it is you're typing on the screen, so that the next thing, either input or output, will take place on the next line. So the other thing that we've talked about is input. And with regards to input, there's a few things that you learned. You learned that in Java there's many different data types. And it's good to think of these data types as different shapes, because each data type has a different size, and you can't create a variable of one data type and expect it to be able to hold information from another. And so when you want to use data types in Java, you have to know the names of the data types. This might be an integer, this might be a character. But you also need to give it a name. And so the way that we saw this happen was in Java you would do int x, there's a space in there, with a semicolon. And that would basically say, I want to create an integer type variable, and we're going to give it the name x. You can't mix data types, but today we're going to focus on some of the important processing pieces that can be done. And so we're going to focus on mathy stuff. And so we're going to show of ways to possibly do some conversion between, let's say, an integer and a character, or a double and a character. We're also going to learn a few important operations like rounding as well as modulus. And we're going to start with the very, very basics. In math, you've learned of the concept of bedmas. In programming, you need to have that same sort of order of operations. And it turns out that, thankfully, they use those same rules. And so, if I have an integer x, and I were to do x plus 2 minus, let's put x in there again, then it would follow the bedmas rules. It will do what's inside the brackets first, and then it will go ahead and do what's outside the brackets. And the same applies to, if we have multiplication and division and things like that. So all the rules, that's the good news today, is that all the rules that you learned in math before, you can apply them again here. Anytime you're uncertain, you can always add in those brackets to help figure out the order, to help enforce a certain order that you're hoping is going to happen. The other important thing I want to talk to you just about basic math is it has to do with division. And so if you remember back in the old school, when you first learned of division, you learned of this concept of, how many times does 5 go into 12? Well, it goes in 2 times, and it has a remainder of 2. In computers, there's a concept and a way of grabbing this remainder piece. And while you might have learned it as being remainder, what it's actually called when we're looking at it, and sometimes the concepts can be a little different, but for our purposes it's going to be identical, it's called modulus. And because in computers it's often desirable to get that remainder piece, it actually has its own symbol in order to calculate it, and that symbol is actually the percent sign. And I can use that in my calculations as a remainder. So for example, let's say I have my integer x, and let's give it a value of 12, sure. Or actually, you know what, let's make it 13, because that's a little easier to see what we want. I can definitely do x I can do x divided by 5. But I can also do x remainder or modulus 5. And this part over here will give me 2, and this part over here will give me 3. Because this is the remainder, and this is the actual division taking place here. Now, many of you might wonder why this answer isn't actually given as a decimal answer. And that's one of the other big pieces of what we need to talk about today is how Java does these calculations, when it decides to give you a decimal answer and when it doesn't. And so we'll get to that in just a second, but for right now, it's important that you understand this remainder piece. It will always give you that integer portion that's left over, that's remaining from your calculation. So that's modulus, and that's your first kind of new operator that you're going to learn about in this course. So coming back to data types for a second, so hopefully you recall an integer we said is a particular shape of data, and it's represented by a certain amount of memory, right? And in this case, it's represented by 4 bytes worth of memory. We also talked about a double, and a double is a decimal number. It has its own range, and it's represented by 8 bytes. Knowing this information turns out to be very important for programming because the computer is going to behave in different ways depending on the types of data you're trying to manipulate and the types of operations that you are trying to do. And I'll give you an example. If I have an integer x which is equal to 5, and let's make another integer y equal to 4. And on the other hand, here I'm going to have a double, and we'll call this a equal to 5 and b equal to 4. So if in my program I go ahead and I say x divided by y, and over here I'm going to do that exact calculation. I'm going to do a divided by b. The results that you're going to get from this operation are actually going to be very different. And the reason they're going to be different is because Java is going to try to preserve the types of the variables that the operation is happening upon. So in other words, if this is an integer and this is an integer, which it is, Java is going to treat this as integer division, and it is going to give you back an integer answer after it's completed that division. What that means is that I'm going to take my 5, I'm going to divide it by 4. I'm going to treat these as whole kind of integer numbers, and that means that when I divide them, my answer is going to be 1. There are no decimals here, no decimals here, so Java is going to do that calculation as if it just wanted an integer answer. It's going to get that integer answer and store it into the data type that you ask for. Here, on the other hand, I have something that's a double on one side, a double on the other side, so the answer that it's going to give is going to have those decimals. When you mix the two, if I were to do x divided by b, as long as some part of the equation is in that larger data type, Java will do the calculation utilizing that larger data type. And so therefore, as long as one part of it is a double, the output that is going to come from this calculation is also going to be a double and will be correct with decimals after it. That's something that gets a little tricky. And so as a beginner programmer, my suggestion to you is that, if you ever want to see doubles from something, make sure it's a double variable that you're using, and that will avoid confusion. and will avoid you doing calculations. Very often a student will come to me and say, I'm doing this calculation and Java's really stupid. It's just giving me a 0. And I know it's not a 0. I'm dividing 3 divided by 4, right? And so you have to keep that in the back of your head, that if you have an integer, and what's even worse, right? What gets even more confusing is that if I want to store this into a double variable called c, and I do x divided by y, you have to remember the way that a computer does this calculation. It's first going to do the work. It's going to do that division, and it's going to treat it as integer division, which means when it's done doing that calculation, it will already be truncated. The decimals will be gone. And just because I'm taking that answer and storing it into a double variable, which is bigger, doesn't mean that those decimals magically come back. This here will not give you any errors, but it will still only return the value of 1. And so you have to keep that in mind as you're programming. You need to think about what type of division you actually want to happen. And this leads into some confusion, which is why as a beginner programmer I kind of suggest that if you're going to want to do stuff with doubles, you might just want to create it as a double. Unfortunately, I do need to get into some of these complications because there are times where you're going to want to leave x and y as an integer. It only makes sense for them to be integers, but you still want to be able to do a calculation with possible decimals. There's also reasons why you sometimes want to take data that's larger and squeeze it into a variable that's smaller, right? There are sometimes reasons where I might want to take a double, which is 8 bytes, and I might want to convert it into an integer which is only 4 bytes. And there is a way to do that, and it has a name, and we're going to get into that next. This that we've been talking about also has kind of a fancy name to it. And it's, let me just jump in. Oh, it's not going to let me change my color. That's terrible placement. The name for this is called truncation. And truncation basically means to cut off. And it's important to realize that that is what is happening here. If I had a slightly different equation and the answer was going to be 1.999999999, Java would still give me an answer of 1. It is truncating. It is cutting off everything that doesn't fit into an integer. It's not trying to do it fancily. It's not rounding. It is truncating and getting rid of everything else. And by default, that's what the programming language will always do when you try to force it to fit something larger into something smaller. Is it will truncate and get rid of, not round. That's part of the reason why we talked about modulus, is that, if it truncates, that's perfect. If I want to know what's left over, I can use that modulus answer to get a remainder of what's left. Okay, so the next thing that we're going to look at is when you sometimes want to fit a bigger piece of data into a smaller piece of data, or when you just want to be able to do your division properly, right? So let's go back here, int x and int y, and let's create a double. All right. So a couple things that you might want to do. First, you may at some point in your program want to do something like this. This is obviously not going to be allowed in Java because remember how we talked about that these are two different data types, two different shapes, but even worse than two different shapes. This one takes up 8 bytes. This one only takes up 4 bytes. How do you take something that could potentially be much bigger and squeeze it into something that's much smaller? And this is a syntax error. It will not even let you run the program if you try to write a program like this. Fortunately, we have a type of notation, and the fancy term for this notation is called casting. And casting is a way for you to tell the computer who's boss. You are the boss. And so if you want to take a double and you want to put that double into an integer, you're the boss. You can tell the computer you want to do that. In some instances. Integer is one of those instances, and so what I could do is I could say x is equal to, and the way that we do this casting is by using brackets, and I'm telling the computer now that I want to take this double variable and I want to squeeze it down into a 4-byte integer and store it into the variable x. And if the computer can do it, it will, but again, it's going to do it in the simplest way possible, which is not to round properly, but to cut it and truncate anything that's left over. And so all you're going to be getting is that kind of whole integer portion and none of the decimals. The decimals will all be gone. And you can do that with some data types and not others. I can turn doubles into integers. I can turn integers into characters. Because remember when we learned about ASCII, we said that ASCII is really just represented as a number. So I could take a number and turn it into an ASCII character. But again, as you squeeze down, there is the potential for some information to be lost. So if you have a really, really, really big integer, why you'd want to turn it into a character, I don't know. But you could potentially lose information when you turn that into a character. But if that integer is in the ASCII range, like 65, you can turn that directly into a character using a technique like casting. Casting will also let you get around that tricky trouble we were just talking about, which is if I want to actually properly divide x by y. So remember we said that this will not work because x is an integer, y is an integer. It's not going to give us that full decimal answer. And so if instead I use a little bit of casting and I say, could you please first turn that x into a double and then go ahead and do the calculation. Now, because one part of my calculation is a double, when Java goes to do that calculation, everything is going to be treated as part of this larger data type, which kind of makes sense. And so the term here is casting. Java doesn't by default like to lose data. It doesn't like to take something large and fit it into something small. As the programmer, you can sometimes force Java to do that, but the programming language is going to do it in a dumb way, and that dumb way is called truncation. And so those are two important terms that we've talked about today, and we're not done. But one of them is called casting, right? The other is this idea of truncation. And then to help us with this whole idea of doing math, we had this idea of modulus, being getting the remainder of something when you do simple operations like that. So, 3 new things learned today. Time to call it quits? Not quite yet. We've still got a few other things, tips and tricks to go over today. And in continuing to talk about basic math, let's add in those integers again. So any math that you can do normally can be done with the computer. So I can always take a variable and I can add to it. And so it's important. This is kind of a little confusing. It looks mathy, but you don't often use variables in the same way in your early math. And what this is doing is this is being called, it's an assignment variable. It's not comparing one side to the other like you often see in math. There's a different way of doing that in programming languages. But this equal sign is saying take whatever the calculation is on the right and assign it to whatever's on the left. So what I'm doing here is I'm taking the 3, I'm adding 1 to it, and that's going to give me a total of 4, and the value of x is now going to be 4. 3 is gone, and that new value of x is going to be 4. There are shortcuts in most programming languages because, let's face it, programmers, like many people, can be very lazy. And so when you have an addition operation like this, x equals x plus 1, you will often see in programming this shortcut, x plus plus. and it saves you a few keystrokes, and so you'll very often see this. And basically that is saying take x and add 1 to it. It's the equivalent operation going on here. Perhaps not surprisingly, there's also an x minus minus, and that was basically the equivalent of x equals x minus 1. Those are probably the most popular operations you're going to see, because adding 1 to a variable and subtracting 1 from a variable happens everywhere in programs. But the laziness of programmers have not stopped there, because you could potentially imagine doing x equals x plus 3, or times 3, or divided by 3. And so there's a notation for that as well. The short notation would be x plus equals 3. And so that basically means take x, make it equal to x plus 3. X equals x plus 3. Not surprisingly, I can do the same with, division. X equals x divided by 3. X equals x times 3. And so this simple notation you'll often see in programming to simplify, to shorten the writing, the typing that needs to be done. You're not required to use it, but you're going to see it. You're going to see it very often. I use them a lot, and so it's important for you to be comfortable recognizing these short forms. And this isn't a new way of doing things, it's just a new way of writing it or displaying it. So the last topic for today is a bit of a doozer. And if you felt like you were at the edge of your seats for that last piece, this piece is going to add a lot of extra complexity. And some programming languages handle rounding fairly easily, and some, like Java, offer so much flexibility in the way to round things, and whether you want to round things for output or you want to actually round the number, that because of all of that power that you have and all those options that you have, it can actually be a little tricky to do what to us is a very simple thing like rounding. And so the last topic of today is actually going to be rounding, being able to round things. And it turns out that there are a number of ways, but I'm going to cover 2 of them. One is when you just want to round for output. You don't want to change the number. You don't want to change that actual variable to get rid of decimals or get rid of precision. You just want, when you display it on the screen, for it to look rounded, and rounded properly, not truncated. The other one is to change the data. And there are 2 different ways of doing that. And we're going to kind of go over both of them. They both involve the use of a new class. And we talked about classes being kind of programs or things that you can do. Well, there's going to be a class called decimal format, and that is the way that we are going to be rounding for output. And it looks exactly like this. Remember, capitalization matters. And then when we actually want to change the data, we're going to use a class called round. And round is going to help us actually round the number to the number of decimal places that you want to get to. Now, to save you from having to follow along with my handwriting, I'm going to pause for a second and add in some code quickly. Alright, so now we're back here with a little bit of code. And you're going to see that the 2 sides look very different. And we're going to start with the one on the right, because in a way this is a little more intuitive. And you can also use the method on the right instead of the one on the left. So what this does is it uses this class called round. And the way that we use round is a little different than many of the other classes that you've used, in that I don't have to use the new command like you've seen with console or potentially with string. All I need to do is use this keyword round. And remember, capitalization matters. And I can access directly certain methods, certain functions that I can do directly from that class round. And one of them is this method called round-to-decimals. And round-to-decimals can take in two pieces of information. One of them is going to be a number. So let's add in here really quickly. Oh, my pen has decided to disappear. So let's assume that we have a double variable x, and it's equal to 12.6. So what this is going to do, well, I suppose if you want to see decimal rounding, then we should make this longer, 12.6958. So over here, what this is going to do on the right is it's going to round x to 3 decimal places using the default method, what you know to be rounding. Remember how I said that Java has a lot of power built into it? Well, you can actually round in different ways. And in some instances, in some environments, you actually do want to round differently. But in this case, we're going to round in the usual way, and it's going to round the answer to 3 decimal places, which means we've got 1, 2, 3. The answer, the thing that is going to be started, well, obviously this needs to be a double. That's not going to be happy. This over here. Remember, we just talked about how we can't fit something bigger into something smaller. So what this will give us is 12.696 as an answer. And yes, to answer the thing that you're thinking in the back of your heads, this would give you an error if you had tried it the way that I initially wrote it, because the answer coming out of round is going to be a double, and you cannot take that and fit it into an integer unless you cast it. But then if you're going to cast it, why are you rounding it in the first place? You could then take that double and you could print it out to the screen rounded, right? But sometimes it's nice to just round to a particular format just for output. And that's what this thing on the left-hand side is doing. And you'll notice that most of the work here is happening in this first line. It uses a new type of class, and you actually have to create an instance of that class, just like you saw with the console. Just like with the console, you only have to do it once, and you can use it throughout the rest of your program. But the magic is actually happening over here. And the number of number signs, I guess, that you're putting after the decimal here is going to determine how it's rounding. This is going to round it to 2 decimal places because I have 2 of these symbols. If I added another one over here, then it would round it to 3 decimal places. And this is just setting up how it's going to round it. And like I said, you can use this variable df here in the rest of your program to just format the number so that it is only 3 decimal places, And the key to doing that is using this format method or this format command. And anytime you have a double that you want to round down to 2 decimal, 3 decimal places, I can use this variable df. I can call the format command and give it the number that I want to round. But remember, it's not rounding the number. All that it's doing is it's going to give you back a string ready for printing that has that number rounded in it. But x stays the same. The precision in x stays exactly the same. And so you'll notice that in this top one, I used it directly in a print line, which is great. Oftentimes you just want to print it. You don't need a variable around to keep track of it. But you could, if you wanted, store it into a string variable. And then you could then use that variable later on to do various things. So rounding is one of those topics you are required to know. You will be asked to round very often in programs. And so now you know that there are 2 ways of doing it. This way will work in most situations. And then because you can just print that final variable to the screen, it also suffices. This is a neat way of just creating a formatter and then using that formatter anytime in your code that you want to do it, as opposed to having to create a new variable and keep that variable hanging around, right? For each time you want to round, this you just have one variable df, and you can use that to format anywhere throughout your code. So that's a lot of topics for one lesson, and we're definitely going to stop here. As a summary, we've talked about operations, important operations that can be done. We've talked about modulus. You also learned a little bit about how the data types and the sizes of data types matter. Java doesn't like to take something large and squeeze it into something small. You learned that there are ways to get around it. And the key word there was casting, being able to take something larger like a double and cast it, force it into something that's smaller. You also learned some shorthand forms for doing some simple arithmetic in Java. I strongly suggest you take notes. As you're learning any new programming language, you should be keeping a little glossary or some notes of some of the techniques that come up. Because as exciting as it is to watch me, I'm sure you probably only want to do it once and not every time you have a Java question. So keep in mind, these videos are an accompaniment to some lessons and assignments from my course. You should be reading the material in the lessons because there are some details that aren't necessarily covered in the videos, and then you should be working on those key assignments as well. That's the video for today. Enjoy some Java programming, and we'll see you next time to talk about the next topic in our journey.